algebraically. So the short of it is if you put -2 into the top or the bottom, you either get 0 over 0 or 0 on the bottom.
Yeah.
Most likely it's 0 over 0. So then you have to factor the top. Top becomes x plus 4, x plus 2. And when you factor the bottom, it's x over x plus 2. So those cancel, and you get the limit as x approaches -2 of what's left over x plus 4 over x. And that's where you put that -2 in.
Oh, okay. So you factor first.
You use a little algebra, and then you do that. If you were to graph this, you could get the answer without the work. I know you got to show work, but that would be ideal. So is that okay, or do we need to go through part B on that?
No, that's okay.
Okay.
But is there a rule that's like if the exponents match, like you just divide by the coefficient?
That's if you go to infinity. So like the limit of this one as x goes to infinity would be this 1 over 1.
Okay, so you can only do that if it's going to infinity.
That's right.
Okay.
That's right. Okay, so I see 6. 6s are, looks like 6 is next. The first one you sent doesn't have a graph that goes with it. That it's got a bunch of limits, like x approaches -1.
Yeah, I probably got like lost in there somewhere.
Okay.
It's number 1, I think.
Yeah, that because I'm assuming you want to do that one first. Oh, there it is. There it is. Okay. I found the graph. So we should go back and do that one because it's somewhat related. There's no work needed for these limit questions. It's very impractical to show anything for it. They're just sort of lookup values. So the limit as x approaches -1. So you find -1 and you say, okay, it's right there. It's where that hole is on the graph. It's not that point because that's where the graph is evaluated. So it's what is the y value that it approaches?
Okay. -3.
Yes, that's why it's -3. Now 0 from the right. So as x approaches, here's 0 is here. From the right is this one. And see how it's going up to positive infinity.
Why isn't it that solid dot? Like, is it because that's like we're looking at what's on the line, or how do you know? For at part A.
It's because you're looking at the curve, not the point, the individual point. This is just something you have to accept for now because we can't go into enough detail. But it's like what is it approaching from each side? It's approaching that value and that value. It doesn't matter that it doesn't exist.
Okay.
All right, so let me pull up the rest of this one. So the next question, let me see if I can get this. Okay. Let's get this snipped and put it over here to the right. Okay. So the limit as x approaches -1, we already did that. That's -3 again. We already did that one. Okay. And then 0 from the left, that's what this minus sign means. 0, here's 0, and then from the left means you're traveling on the curve this way, that direction. So that's why it goes down to minus infinity. So all of these are y values. I guess that's an important thing to think about is these are y values, not and the one this value here, those are the x values.
Okay. So what about when it says x approaching 0, but no positive or negative sign? Why is that DNE?
So this, for something to, when it says 0 without the positive or the minus, it's really asking, is the limit as x approaches 0 from the left equal to the limit as x approaches 0 from the right?
Okay.
So that it has to approach the same thing. It's like I'm coming to a value from this side, I'm coming to the value from this side. Do they approach the same thing?
No.
Well, in this case it does, but not here.
Not in the graph, yeah.
Right.
Okay, I think I'm good on that then.
Okay. So then the next problem I saw in order was 6, I think.
Yeah.
Where is it? There it is. Okay, copy image.
This might have 2 images too, I think.
All right, I've got the question snipped in here. It says the following curve is a model of a certain country's total prison population as a function of time and years. Okay. So it says over the period 5, 10. So that's where you're looking at from 5 to 10. What we're trying to figure out, which one's true, which one's false. So let's look at the one that it says here that's true. The instantaneous rate of change is decreasing. So the instantaneous rate of change refers to the derivative,
Okay.
and that's the tangent line slope. So like at 5, it's got a slope that's going up pretty to the right, but here it's going less and less up and to the right, and then here it's flattening out. So it's like the slopes become more flat.
Okay.
It's steeper, and that's what the second one means. If it were increasing, let me show you what this would look like. It would be flat up, kind of like that. That's what it would look like if it was increasing.
Okay.
And that's decreasing.
Okay.
But it could also go the other way. So like if these are going up, it could also go down to the right and be increasing or decreasing. But I think that's that. So for the next one, for B, the instantaneous rate of change at t equals 4 is greater than the average rate of change over the interval. Okay, so the average rate of change, the ARC, average rate of change, that's just your regular slope. I actually remember us working on these problems here. So from 0 to 10, it's like, what is the line that connects those? It's that slope right there. And then the tangent line at 4, see how it's steeper than that one? That's why it's greater than.
Okay.
And that's what it's referring to. And I think you're right. There's some more. I remember there being a few more questions associated with this. Let's see if I can find them. Not finding them. Yeah, not seeing that. Not seeing them in this grouping.
Okay.
So you could send them, or we could just move on, whichever you want. I'm not seeing them in here. They do it another way. Wait. There is. Oh, there's one with iPhone models. That's not the prison population. There it is. I found it.
Okay.
Okay. All right. So the over the period 0 to 10, the instantaneous rate of change of n is increasing, then decreasing. So the instantaneous rate of change refers to the derivative, which refers to the tangent line. So that graph that we had here, I mean, it kind of does this thing where it goes like that, and then it kind of flattens out. So these tangent lines get steeper, and then they get less steep.
Yeah.
And that's why that's correct.
Okay.
I mean, chances are you get the same graph,
Yeah.
but you'll have to memorize the answers or write them down on your reference sheet if you get one. Part D, according to the model, this country's total prison population was increasing the fastest around what year? This is asking where is the tangent line steepest? Steepest. So if I go back to it, you'll see that it's steepest right here around 5-ish. Well, I don't know, maybe 4. I don't know, maybe it's at 4. Can't remember.
Okay.
Yeah. So the answer wouldn't be 3. It would be 1990 plus whatever value you get.
Yeah.
Roughly estimate the instantaneous rate of change at t equals 4 using balance difference quotient with h equals 1.5. Okay, this one's pretty tough to do. Let me snip in the graph again so that we can have that available to do. So this is part D. Okay, so part D. So it's saying at t equals 4, so it's right there. And this h equals 1.5 means you're going to go over 1.5. So down right here at 5.5, you're going to get that value there. What's that y value there? It's 1.55. So you're using 2 points. You're using 4 comma 1.5. That's your first point, and then you're using 5.5 because that's your h. That's how you get it. It's 4 plus 1.5 comma, and then you just read off the value 1.55, and you just have to find the slope. Even though it says when it says roughly estimate the instantaneous rate of change, they're saying find the slope, find the ARC. So the slope here is 1.55 minus 1.5, y2 minus y1 over 5.5 minus 4. Apparently that equals 0.033. This number is directly related to this number down here.
Okay.
So because it says 0.033 million, you take this number and you multiply it by 1,000,000. And that's how you get this number down here. That's how it becomes 33,000 when you multiply by 1,000,000. And it's increasing because it's going up and to the right. The graph is.
Okay, that makes sense.
Say that again?
That makes sense.
Okay.
You can move on.
All right. These are all questions you've done before. So that that to me, that would give me some confidence. May not feel like it, in the moment, but you have seen all these. So all right. So let me snip in question 7. Question 7.
Yeah, I recognize all these problems, so that's good.
Great.
I just need to really tomorrow. I have nothing else to do besides this, so
Okay.
I'll definitely come back with more problems to work on. I'll finish this review.
Okay, so average velocity is this average. Whenever you see this word average, that means slope. And slope is like slope formula. It's y2 minus y1 over x2 minus x1. Now, in this case, you don't get points, but you do get this function here. So the function is from a to b. So this y2 is s of b, meaning you're going to put 3 into this function, minus s of a. You're going to put 1 into this function over b minus a.
Okay.
So we have to go over to the function and figure, okay, well, what is s of 3? So that's 1,050 minus 70 times 3 minus 16 times 3 squared. So we'll need to get that number. I'll grab my calculator and I'll do this as well. Okay, so that's 696. And then we need to do the same thing at 1. So that's 1,050 minus 70 times 1 minus 16 times 1 squared. And that's 964.
Okay. I got
so
that too.
So we get 696 minus 964 over 3 minus 1. And I get negative 134.
Yeah.
All right, so that should be that, okay? The instantaneous velocity, that's when you take a derivative of s. So So that's just power rule. S is equal to minus 70 minus 32t.
And then plug in those numbers. Oh, 3.
Yeah, I'm sorry, S prime, or yeah. So it's just power rule. And then you're going to do S prime of 3. So you can put 3 in for t. Let me know if that's the same, but
yeah, I got
that's
that.
what I got.
Yeah. Okay, we can move on.
All right, so question 7. I see an 11, 11, 12. I'm going to go to 11, I guess. All right.
Also, what is the constant multiple rule?
For derivative or integrals?
Derivative.
Okay, so derivative. So if you have c times f of x, the derivative is c times f prime of x. So that constant just comes with it.
Oh.
That's all it means. It's probably much clearer now that you've done a bunch of these already.
Okay, it was just on my review as like one of the things to like select, and I just forgot what it means.
Yeah, they'll ask you like, which derivative rule do you use for this problem? And
Yeah.
if you see a number in front of x, it's constant multiple.
Okay.
All right, find the equation of the tangent line to the graph of the given functions. To find a tangent line, you have to first evaluate the function at the point. So that's 2 over 1 squared, which equals 2 over 1, which equals 2. The next thing you have to do is find the derivative. So f of x can also be written as 2x to the minus 2 power. And to find its derivative, that's just power rule, minus 4x to the minus 3 power. But then you have to do a little bit more. You have to evaluate it at that point there. So you have to take the derivative, which you just did, and then evaluate it at 1 minus 4 times 1 to the minus 3 power. That ends up equaling minus 4. So the equation of the tangent line is y minus y1 equals slope x minus x1. That's the preferred one because you have a slope right there. Your derivative is the slope. And your x1 and y1 come from here and there. Like after you put the value of 1 in, that's your y1. So it's y minus, what's your y value? 2 equals negative 4x minus 1. And then you just simplify this to get the y equals minus 4x plus 6. So to choose the graph, I know there's 4 graphs here. You'll be able to choose it because only one of them will go through the right b value and have the right slope, meaning like because it's negative, it goes down and to the right.
Okay.
You'd be able to choose that without having to graph it, but you can. The other thing is, I guess, is this, this is the blue over here is the wrong graph. So there's a couple things there. If you have a graphing calculator, you may just graph the original and graph that line and make sure which one looks the same.
Okay.
All right, that was 11. I think I said I saw 12.
Yeah.
And then I don't know which one we'll go to next. Oh, this one no, that's part of its question was on another image. Okay. iPhone sales, okay, are given by this equation. Great. It says compute the derivative. So the derivative of this, that's just using power rule. You got that right. How fast were the iPhone sales changing in the second quarter? So they tell you what T is. So you took that number and you put it in for T and you got that value.
Yeah, I think there's another part to this.
Yes, and that's what I have to go grab that from another picture.
Okay.
here's part B. All right, part B, it says, which of the following is true? Okay, so the issue is we got this interval from 2 to 4, So we're looking from here to here. So let's just look at tangent lines. Steep, less steep, less steep, less steep, less steep. What does that mean if it's getting less steep?
Decreasing.
That is
Decreasing.
decreasing. That's decreasing, and it's a little bit awkward because it's the function is increasing, but it's increasing at a lower rate.
Yeah.
This is like you going forward, but you're applying the brakes.
Okay.
That's the best example of that. So that's why we can get rid of this one and this one because it doesn't decrease. It is increasing, but so what would a faster and faster rate look like? So that would be if you had a parabola like that, flat.
Okay.
A little more, a little more, a little more, a little more, and so on.
Okay, yeah, that makes sense.
That's what that would be, and then obviously that's why that one is correct. Okay, I'm gonna just scan the pictures again to see where to go next. I see a 30. I see 23.
Yeah, at this point, you can go out of order. I just picked some random ones that looked hard.
Okay. All right. The average price of an apartment is given by this equation. They want you to find P of 8. P of 8 means to put 8 into this equation. So 0.17 e to the 0.10 times 8. So just make sure you're comfortable with that. P prime of 8 means you have to take the derivative of this. So P prime of t equals. So we're going to use the constant multiple rule you were asking about. That means that that constant comes with it. The derivative of e is, do you recall that?
Is it just e to the point?
It's itself. It's e to the 0.10 t times the derivative of this part.
Oh, that's right. Yeah.
0.10. So I wrote it this way. I was like, I wrote e to the kt or e to the kx, and then the derivative is ke to the kx. You always have to multiply by the derivative of that, or whatever's in front, basically. Okay, so then this p prime of 8, you get from putting 0.17 e to the 0.10 times 8 times 0.10. You do that and you get a number out.
Okay.
That's just a calculator thing there.
Okay. Yeah, we can move on.
All right. I'm still going to try and do these in order. I think it'll be most helpful. We'll do 30 next. All right, let me just make this a little smaller so we can have it all on one screen. All right, so assume that it costs, okay, so they give you a cost function. They want you to minimize average cost. So average cost is C bar of X, and that is C of X divided by X. So you have to take this function here, and to find C bar of X, you have to divide this by X. So it's 115200 over X plus 340 because the X's cancel, plus 0.1235x because X squared cancels with 1x. So to minimize average cost, you have to take a derivative of this. You have to find C bar prime of X. So we're at the part of the course where you got to be just very clear on like, okay, derivative, I do one thing, integral, I do another. So the derivative of this first one, go ahead.
I was just saying, yeah, sorry, my voice is like...
it can be very confusing. You'd be like, oh yeah, do I add, subtract? So just maybe do all the derivative ones together, do all the integral ones together. Plus 0 plus 0.0005. And then you set this equal to 0. So you set this equal to 0, and then you solve for x. Okay, so to do that, to solve this equation for x, I'm going to just move this to the other side of the equation by adding it. That way, everything is positive. Okay, and then you can cross multiply here. So you get 0.0005 x squared equals 1152.123. And then you divide by this number. So 1152.123.0005, and then you take a square root. So x equals the square root of this large number. And that's the answer to part A. So whatever that is, and actually I guess we should get that value because we're going to use it in part B. So it also should be nice, I think, because it doesn't say to round. So that's kind of one of your checks. Like if your answer doesn't work out really well, and this one here is 48,000, you know you've done something wrong. Okay, so the first value here is 48,000. What is the resulting average cost? So they're referring to this equation up here. So the okay. Part A, you had to take the derivative, set equal to 0. But here they're just saying put that value back into this original function for x. Let me write a note to put 48,000 in for x.
But in the average cost function, not
yes.
that. Yeah.
Because it says average cost, and that's how I know that there's nothing else I'm doing to interpret that besides that.
Okay.
So that ends up being 388. Notice it doesn't say to round, so we expect it to be nice. I don't know how to answer that. This is like an econ question. It's like, I don't know how to answer this. I guess I would just remember what it is.
Okay.
Because it's asking you to compare marginal cost and average cost. I guess you could take a derivative of this and then compare it. So let's do that. So the marginal cost is C prime of x, and that's 340 plus 0.0005x. And then you could put that 48,000 in here, and whatever that number is, which we'll get, we're going to compare it to that number and see which is bigger, which is smaller.
Okay.
So let me do that here. Okay, so that it ends up being 364. C prime of 48,123 equals 364. So the oh well, that still doesn't help us. So it's like we have to pick a number less than the optimal number, and then compare the values. So I know this doesn't help you probably at this point, but I was going to say, ask the instructor.
Honestly,
or just it's going to be larger or smaller.
It doesn't really matter.
It'll probably be the same if you get this question again on the test. Okay. Whatever it ends up being.
Yeah, it's fine. I haven't seen that question that much, so that's fine. I think it's fine. We can move on.
Okay. Yeah, always tell me if I'm spending too much time on something, because I want to make sure you get the most out of this, and I'll spend too much time on stuff that you don't need me to. So we're moving on to 35. Definitely remember us working on these problems. These are rates, and you've got you got a few things going on here. So first thing, it says the radius of a circular puddle is growing at a rate of 15 centimeters per second. That's r prime. I know that because it tells me the radius, and it's distance per unit time, and radius is in distance. The per unit time is because it's a rate.
Okay.
Okay, so part A says, how fast is its area growing? Well, the area, the first thing you do is write the formula for area. It's pi r squared. Okay, then you have to take a derivative. So a prime equals 2 pi r prime. So this is where it's different than maybe other things. Like here, when you take a derivative with both variables, you put this little prime here. Hopefully that's familiar, or something you know.
Yeah.
Okay, so now we're gonna figure out, well, what is it asking for? It's asking for how fast is the area growing? That's this one. That's what we're trying to find. So do we know the radius? Yes, the radius is 30, and the r prime is 15. So that ends up being 900 pi. It's just a round to the nearest integer, so you got to throw that into the calculator. And you get 2827. Okay, now we can move to part B. Okay, so it says, how fast is the area growing at the instant when it equals 49 square meters? So it's kind of the same problem in some ways. It's pi r squared, take a derivative, a prime equals 2 pi r, that's power rule, times r prime. And we're trying to find this. We know that r prime equals 15 because that's given for both parts. But what we don't know, this is the one we don't know. We don't know the radius this time. What we do know is that the area is 49. So you use this formula for area. If A equals 49, you can solve for R. Okay, so let me just create some room here to show you that. So area, I'm gonna come down here with that. Area is pi r squared. The area is 49, and you want to solve for R. So you divide by pi, and so you have r squared equals 49 over pi, and then you take a square root. So r equals the square root of 49 over pi, and that's what goes in here for r. So your a prime is 2 pi, the radius is square root 49 over pi, and r prime is 15. That's given. So the key is in part B is you have to solve for the radius, whereas in part A, they give you the radius. Let me just show you that again up here. They give you the radius in part A. In part B, they give you the area. You can use area to find radius. And then you get your number out, whatever that is for that.
Okay, so then you plug back in a prime equals 2 pi and then the square root of 49 over pi times 15.
Yes.
And in part B, you're trying to find a prime?
In both parts, you're finding a prime. But in part A, you have all the numbers. You just plug them in. Part B, you have to find one of the numbers to plug in. And you know that because of the units. The units are centimeters squared. That's area. Area per unit time is a rate.
Okay. We can move on.
All right. Let's see. 36, I think I saw. 35, or there's 36. Okay. Oh, this is a good one to do because it's related. All right, a rather flimsy spherical balloon. Okay, let's get to the question here. Calculate how fast the radius is growing. Okay, so they want how fast is the radius growing. They give you this formula. They tell you V equals 4/3 pi r cubed. Now, you're a good calculus student now, so you know to take a derivative of that. That's 3 times 4/3 pi r squared r prime. And if we just simplify a little bit here, it's 4 pi r squared r prime.
Yeah.
Now, what is it asking for? The radius, r prime. That's asking for this. So r prime equals v prime over 4 pi r squared. So you need, like if you're making a list here, you need v prime, and you need R. Do you have either of those? Well, let's go back and read the problem now. Radius is 5. Got that now. Check. And V prime is 12. So you have everything you need. You just plug those values. Then plug them in. So I'll do that as well.
Okay.
Let me get to where I can do that for you as well. So that's 12 over, and this one, I guess you have to be a little careful to make sure you have parentheses in the bottom. I'm just going to do this calculation. 4 times pi times 25. Okay, so it's 0.0382. Not sure how many decimal places you need to go out to on that. I guess it says 2.
That's what I want to.
So it says 0.04.
Okay.
All right. 36 is done. Let's see. After that, I see 58, 59, 37. Okay. Ooh. So 37 is this one that it's a really long one, and we've done it before, and it's pretty challenging. You may want to check to see if it's actually on the going to be on there, because this one requires you to when you take your derivative, you use product rule, and then you have to set it equal to 0. So if you end up using like the quadratic formula, I would definitely ask your instructor if this particular one, with this kind of formula will be on there, because it's pretty heavy and involved.
Okay.
For a final exam, like it's not the one where you're just testing, sort of like making sure, okay, does the student know the few things that I want them to know? It's very specific. 38, on the other hand, is much better problem to do. I think we've done this one before, but we're going to do it again because it's a really good one to talk about how to do these formulas. So you're finding price elasticity of demand, E. E equals minus P over Q times dQ dP. So we need 3 things. We need price, quantity, and then the derivative. So this is your P. P equals 2,800. Q is given up here. Q is 9,800 minus 2 times 2,800. Q is 9,800 minus 5,600, which is 4,200. So that's Q. We got 2 of the pieces. Now dQ dP, you're taking a derivative of this thing up here. It's minus 2. So the elasticity of demand is minus 2,800 divided by 4,200 times negative 2.
Okay.
And from my experience, this number is always positive. And so I got 1.33.
Yeah.
Now this is the one I keep asking, because I'm like, which I don't know, because I couldn't figure out how they come up with this number.
Oh yeah, I forgot about that.
So you may want to make another note here to ask, because it's a part of this. Now the answer is, if it's elastic, I think they're supposed to charge more, and if it's inelastic, they're supposed to charge less. So these are tied together.
Okay.
Okay. Now, so I would just shoot off an email to the instructor, or maybe go back and look at your notes from class to see how to figure that out, because I really don't know how they're doing it in this class, because to me it's based on this number. If this number is bigger than 1, it's inelastic, but it didn't seem like that was right in this class. So I don't want to pretend like I know, because I haven't been able to give you the right answer. So now, to maximize total revenue, that's part B. Maximize total revenue. So to do that, revenue is price times quantity, and your P is the variable. So this is P times 9,800 minus 2p. So we can expand that. That's 9800p minus 2p squared. To maximize or minimize, you take a derivative. That's not the derivative yet. Let me not do that. So r prime is 9800 minus 4p. Set that equal to 0. Divide by 4. So p equals 4900, so 2450, I think. You check that. That's this first part.
And then you plug the revenue.
Exactly. So the revenue B R of P is equal to this 9800 P minus 2P squared. So you put 2450 in for P. 9800 times 2450 minus 2 times 2450 squared. Get that number if we want.
Okay.
Yeah, it's pretty big. It's 112,500,000. Actually sounds about right for a university, a small university. I think
Okay.
ASU's revenues are billions.
The
Okay.
trillions?
I'm sorry?
The trillions?
Billions. I think ASU's revenues are in the billions. They have a ton of online students now and other things.
Yeah.
All right, so 60 is on the list, 51, 52. Okay, let's do 51, I guess. Do you have another lesson scheduled with me, or is this it before the final?
There's one tomorrow.
Okay.
At 3.
All right, so I'm gonna just keep doing the derivative ones, and then maybe that we can do integrals later on if you have more here, because this is another derivative type question.
Okay.
Well, actually, I take that back. This one moves to integrals. Is that all we have left on this?
I think so.
Yeah, 58 is also, yeah. So all the rest of these are moving into integrals. So find the total displacement of the ball, okay, between 1 and 7 seconds. So I believe total displacement is the integral from 1. Is it 7? Sorry, I can't find. Yes.
Is it cut off?
Yeah, I got it. It was cut off on my screen. 88 minus 32t. So you take this function, put it there. You put the limits of integration there, dt. So this is just power rule. So it's 88t minus 16t squared. And then you evaluate that from 1 to 7. So taking the derivative of this gets you back to the original one there.
Okay.
Okay, and that's like a check you can do. So this is 88 times 7 minus 16 times 7 squared minus, big parentheses, 88 times 1 minus 16 times 1 squared. Now this is where I also said, hey, just throw this in your calculator. Show the work, but you got to get the right number because that's what you're trying to get here. So let me get that number. It's like math 9, I think, is the integral.
Yeah.
On there.
What, 288?
Was it negative?
No.
Okay, so 288.
Yeah.
All right. Can you check that? Because this wording is a little bit odd. I don't know if we need to break this up into 2 integrals.
Oh, yeah, I'll check. Is this 51?
Say that again?
This is problem 51.
It is, yes. Yes.
It's negative 240.
Yeah, that's what I was. That's what I'm surprised. Let me just check this here on my. Let me use a different calculator for this. Integral 88 minus 32x from 1 to 7. Yeah, I get minus 240 when I throw it in the calculator.
Oh wait, was I supposed to put in the 88 minus 32?
Yes, yes, yes. That's what goes in the
fine.
calculator.
Okay.
So then, so because it's negative, that's why it says lower. The lower is because it's negative there. So that's 240 feet lower after 7 seconds.
Okay.
All right, let me see what else we can do here. We're doing real quick. Go back to get the email. There was one. Yeah, this one we can do real quick because it's just a calculator question. 58 is what I'm snipping in. All right, the annual revenue earned by Walmart is given by this function here. They want to know the total revenue. So the total revenue is integrating the revenue function, 176e to the 0.079t from 0 to what year? Oh, so it's not 0 because it says from 2000. It's kind of cut off here. It says from 2009 to 2014. So 2009, that's 9 to 14.
Okay.
So you're going to integrate this from 9 to 14 and get that value. So integral 176. I get 21. I get 2197.15, but it's just rather near as 10 billion, so that's the tens place. So that would end up being 2200 billion for that one.
Okay.
All right, so we're going to stop here. Queue up your questions for tomorrow and be happy to help. I'll send out the notes in the screen recording here the next couple hours.
Okay. Thank you so much. See
You're
you
welcome.
tomorrow.
See you tomorrow. Bye now.